This is a video on the segment addition postulate. So what the segment addition postulate says is that if you have line segment AB and you've got point B which lies somewhere in between AC, you can state that AB plus BC is equal to AC. And remember in class we talked about if you have a rope, right, that's 5 feet long, and if you cut it in two pieces, it doesn't matter what lengths the first length and the second length are. When you put them back together, you get the length of that rope. Okay? So let's go ahead and do an example. So here we've got line segment. We've got A, C, and then we've got B somewhere here in the middle. All right. So AB is equal to 19, and AC, which is this whole distance right here, is equal to 31, and we want to know what this distance is. Okay, so this line segment postulate says that AB plus BC is equal to AC. Okay, so all we're going to do is we're going to start plugging stuff in. So AB is equal to 19 plus BC, we don't know what BC is equal to 31. So if we subtract 19 from each side, we get BC is equal to 12. So we're saying that this is equal to 12. Okay? Then we check it by knowing that 19 plus 12 should be equal to 31, and 31 is equal to 31. Therefore, that's correct. All right, so let's do one that's a little bit more difficult. Okay, so there's our segment A, C, and then B is somewhere in between. All right, so AB is 7x plus 3, and BC is 3x plus 13. All right, the segment addition postulate says that AB plus BC is equal to that whole segment of AC. All right, so now we start plugging in. AB is 7x plus 3. BC is 3x plus 13. And AC, I didn't tell you guys that, sorry, AC is equal to 56. Right, so now we put them together. 7x plus 3x is 10x. 3 plus 13 is 16, equals 56. Then we have, subtract 16 from each side, 10x is equal to 40. So therefore, x is equal to 4. Okay, I'm going to write this up here on the top. So x is equal to 4. All right, now I'm going to go and I'm going to erase my work here so we can plug stuff in. All right, so x is equal to 4, and it wants to know the segments. So AB is equal to 7x plus 3, and we're going to plug in 4. So 7 times 4 plus 3 is 28 plus 3, which is 31. And BC is 3x plus 13. So 3 times 4 plus 13 is 12 plus 13, which is 25. All right, and is 31 plus 25 equal to 56? It is. So 56 equals 56. So that is correct. All right, one more example, and we're going to do it using quadratics. All right, so let's see. We'll do one from class today. So we've got A, C, and B. All right, AB is equal to, okay, x squared plus 7x. Okay, BC is equal to 3x plus 2, and AC is equal to, it told us, of 26. Okay, so we know that the segment addition postulate says that AB plus BC is equal to AC. So we're going to plug in. AB is x squared plus 7x. BC is 3x plus 2. And AC is 26. Okay, so from here you're going to simplify. So we have x squared plus 10x plus 2 equals 26. Remember, if you have a quadratic, we want to set it equal to 0. So that becomes x squared plus 10x minus 24 is equal to 0. And then when we factor that, we get x plus 12 minus 2. So that means that x is equal to negative 12 or positive 2. Now, remember, we're always going to do we're always going to use our positive values. So we're going to do x equals 2. Okay, so we're going to get rid of all this work, and then we're going to plug stuff in and figure out what it is. All right, so AB is equal to x squared plus 7x. So that's 2 squared plus 7 times 2. That's 4 plus 14, which is 18. And then BC is 3x plus 2. If we plug in 2, we get 3 times 2 plus 2, which is 6 plus 2, which is 8. When you add 18 plus 8, you get 26, which is the correct answer. All right, you guys have a good night. I'll see you tomorrow.
The following is a selected video from yourteacher.com, where you can browse over 450 complete math lessons with example videos, interactive practice problems, self-tests, and more. Try a complete lesson today at yourteacher.com.
In this problem, we're given the diagram shown, and we're asked to find the length of segment AB and the length of segment BC. Remember that the segment addition postulate tells us that if B is between A and C, as it is in our diagram, then the length of segment AB plus the length of segment BC is equal to the length of segment AC. Since the length of segment AB is 6x plus 5, the length of segment BC is 4x, and the length of segment AC is 45, we can set up the equation 6x plus 5 plus 4x equals 45. Solving this equation for x, we find that x equals 4. Now we can plug 4 back in for the x's in the original problem to find the lengths of segments AB and BC. So the length of segment AB, which is 6x plus 5, is 6 times 4 plus 5, which simplifies to 29. And the length of segment BC, which is 4x, is 4 times 4, or 16.